Hello, how are you doing? This is Mike Johnson here, and in this video we're going to talk about how to determine the zero of a polynomial, or the zeros of a polynomial. There may be multiple zeros, and in fact some zeros may occur more than one time. So we're going to discuss the multiplicity of a zero, how often that zero occurs in one of our next videos. However, at this point we're just going to talk about the process of determining the zeros of a polynomial. So first of all, I would like to discuss some nomenclature, and let us discuss zeros, and let us discuss what a zero of a polynomial is. It's going to be any point where the polynomial crosses the x-axis. And that's always going to occur at a point when y is equal to 0. So y always equals to 0. So we often say this is a constant comma 0. It's a constant comma 0. Y equals to 0 and c is a constant. And c can be any real number. So it can be any real number. So there are some other terms for zeros. For example, zeros are, I always spell zeros wrong. Zeros are synonymous with x-intercepts. And these are synonymous with solutions. So x-intercepts, zeros, and solutions are all the same term. So if you want to determine the zero of a polynomial, if you want to determine the zero of a polynomial, set the polynomial, it's just that simple, set the polynomial equal to 0. So let's go ahead and look at an example. Let's go ahead and look at the example, and we're going to ask for the zeros of the polynomial. So let us say that we have f of x equals to x minus 3 times x plus 4. And if we want to determine the zeros of this polynomial, or where this polynomial crosses the x-axis, we're going to set x minus 3 times x plus 4 equal to 0. And now we can use that zero property, that zero multiple property, where since we're multiplying two terms and they're set equal to 0, we can set them equal to 0. So we're going to add 3 over here, and we get x equals to 3, and this is equal to 0. We're going to subtract 4 over here, and we get x equals to negative 4. So we have two zeros of this polynomial, at 3 and at negative 4. So we could say that our zeros exist at 3, 0 and negative 4, 0. And you always want to indicate them as points. Sometimes you can be specific and indicate them as x equals to a value. However, that's not always as descriptive, because that could also be the equation of a vertical line. So you want to be very careful when you indicate that to your instructors. Let's go ahead and try another example of determining the zero of a polynomial. So let us say we get f of x is equal to, let us try x to the fourth minus 1. So let us go ahead and try x to the fourth minus 1. And if we want to determine where this equals to 0, we have to set x to the fourth minus 1 equal to 0. So sometimes some polynomials may be factored. Actually, let's go ahead and try a different example. Let's go ahead and say x to the fourth minus x squared. Let us go ahead and look at that polynomial. So if we want to evaluate x to the fourth minus x squared, we are going to set x to the fourth minus x squared equal to 0, and we're going to have to factor in order to solve this. So we have to factor in order to solve this. So we are going to factor out a GCF, which is in fact x squared. And that's going to leave you with, if you take out 2 x's from x to the fourth, that'll leave you with 2 x's, which we indicate as x squared. If you take out 2 x's from negative x squared, that leaves you with a negative 1. And we're going to set this equal to 0. So now we have two terms. We have the first term and the second term. We're going to have x squared equal to 0, and then we're going to have x squared minus 1 equal to 0. So notice here that the exponent is a value of 2. This is the same thing as me saying x times x equals to 0. Is that important at this point? No, it's not. But just remember that this actually occurs twice. So when we solve this, we're going to get x squared equal to 0. We're going to take the square root of both sides, but we'd have to add a plus or minus, and we know plus or minus 0 is still equal to 0. But we would say that this 0 occurs twice. So I'm going to put a little note here. Note that x equals to 0 occurs twice. And that may not make a lot of sense at this point, but just remember that the x equaling to 0 occurs twice. It has a multiplicity of 2. So now if we want to determine this 0 over here, we'll see where these zeros occur if there's more than one. We're going to factor this, so that's going to be the difference of two squares. So remember, a squared minus b squared equals to a minus b times a plus b. And we have two perfect squares here, x squared and negative 1. So we're going to have x plus 1 times x minus 1 equal to 0. And just to follow with our idea of occurrence, notice these exponents here are a value of 1. And this is a value of 1. So they have exponents that are values of 1. So their multiplicity, or how often they occur, is just one time. Now we can set each one of them equal to 0. So we can set x plus 1 equal to 0 and x minus 1 equal to 0. So we get x plus 1 equals to 0 and x minus 1 equals to 0. And x equals to negative 1 and then x equals to positive 1. So notice we're going to have 1, 2, and 3 zeros here. So we have 1, 2, 3 zeros. We might have to list them as points. So list them as points. We're going to have 0, 0, because remember with x-intercepts or solutions, the y value always equals to 0. We would have negative 1, 0 and 1, 0. So that is a parentheses, not a C. You have to be careful about that. So we have 1, 0. So we're going to have three solutions with this question, and we recognize that one has a multiplicity, or one occurs twice, which is indicated by that exponent. So let's go ahead and say we wanted to test a 0. So let's go ahead and say we want to determine if a given value is a 0. So let us consider the function. Let us say f of x equals to x cubed plus, let's say, x squared minus 17x plus 15. And I ask the question, does a 0 exist when x equals to 2, or we'll say or, because it could occur at both, and or x equaling to negative 5. So if we want to determine if a 0 exists at those two values, all you have to do is plug in and determine if this equals to 0 when you plug it in. So let's go ahead and find f of 2. F of 2 means everywhere we see an x, we're going to plug in 2. So we're going to have 2 cubed plus 2 squared minus 17 times 2 plus 15. So I plugged in. This will give me a value of 8 plus 4 minus 34 plus 15. 8 plus 4 is 12 plus 15 gives you 37. 12 and 15 is 27. 27 minus 34 is negative 7. So negative 7. So therefore we know that x equals to 2, x equals to 2 is not a 0. X equals to 2 is not a 0 because it isn't equal to 0. So now let's test f of negative 5. So we're going to have negative 5 cubed plus negative 5 squared, making sure you plug them in with parentheses, minus 17 times negative 5 plus 15. So what is this? That's going to be negative 125 plus 25. 17 and 5 is positive 75, I believe. And lastly, we're left with positive 15. So negative 75 plus 25. That would be correct. So negative 125 plus 25 is negative 100. And notice here, negative 17 times 5. So that gives us a value of equaling to 0. I believe that is correct. We're equal to 0 there. Positive 25, negative, positive, and positive 15. Yes, correct. Therefore, x equals to negative 5 is a 0. X equals to negative 5 is a 0. So you can plug in to determine if values are zeros as well.